Okay, so this is number 7 from the Physics 1 textbook. And on this one, I went ahead and drew a sketch of everything that was in the problem. So it was a spin-off of number 5. So on number 5, you went 12 meters in a direction 20 degrees west of north. And then once you got up here, you went 20 meters in a direction 40 degrees south of west. So kind of like that. But this time, we had to do the opposite on the second set. So it said to repeat the problem, but for the second leg, you're gonna walk in a direction 20 meters. You're gonna walk 20 meters in a direction 40 degrees north of east. So I've got east here, and then 40 degrees north of that is right there. So I drew that in. And then it asks us what angle we're gonna see for this point, and what's the length of our new vector. So our resultant vector R, we wanna find the length of it, and then we wanna find theta, which I will just label here, maybe. Yeah. Okay, so the first thing we need to do is find our components. So for our first component, so what that means is that we need to find out how far up and how far over this vector is. So in order to figure that out, we have to figure out how far up and how far over each of these vectors are. So one thing that you should notice or look for is in what ways are these vectors working together, and in what ways are they working against each other. So if you look at these two vectors, you'll see that they're both going up. So the y component is working with the y component. But one is going toward the west and one is going toward the east. So their x component is working against each other, or are working against each other. So this one is actually going to get subtracted away from this one, just the x component of that. So that's something to look at and kind of understand conceptually based on what your drawing looks like. Okay, so let's start with our x component. Let's see, so r of x is going to be, so that's going to be the x component of this vector plus the x component of this vector. So the x component of this vector is here, right? And our angle is, let's see, so that's 20, so we can call this 70. And then we can say that we know our hypotenuse, right? Which is nice. So then we can use our trig functions. So then we're going to say, okay, so we've got 70 degrees and we're looking at this adjacent angle, right? So we're going to say 12 times 70, times, what are we doing, adjacent angle? Cosine of 70 degrees. And then this is our x, so this one's negative, right? This one's going against us. And then we need to look at the x component of this guy here. So that is going to be here. Right, that's where we'll find that x component. So we are trying to find, once again, our adjacent. So we're going to say plus 20 times cosine of 40 degrees. And that should give us our x component. So I've got 70 cosine times 12 plus, 70 cosine times 12, so switch the sign, plus 40 cosine times 20. And that gives us 11.2. So that is our x component. Now we need to find our y component. So this is going to be basically the opposites, right? Because now instead of finding our adjacent angles, we're going to be finding our opposite angles, because that's our y components. So on the first one though, but remember these ones are working together, so there's not going to be a negative sign with our y components. So for our first one, we're going to have 12 times cosine of 70 degrees again, plus, sine, plus 20 sine of, 40 degrees. I don't know what's happening. All right, so that is going to be 70 sine times 12 plus 40 sine times 20. So that's going to give us 24.1 meters. Okay, so now we have the legs of this. So we've got this one and we've got this one. So this is 11.2 meters and this is 24.1 meters. So now we can use the Pythagorean theorem to find the length of r. So we just do 24.1 squared plus 11.2 squared equals that. Square rooted is going to give us 26.6 meters. Okay? Now we need to find this angle. But that is no problem because we know the lengths of both of these sides, right? So we can do tangent, inverse tangent of opposite, which is 24.1 over adjacent, which is 11.2, in order to find theta. So we get 24.1 divided by 11.2. That is not correct. 24.1 divided by, what is happening? 24.1 divided by, 11.2 equals that. And then inverse tangent of that is 65 degrees. Now that doesn't mean much until we think about what that means. So that is 65 degrees north of east. Okay, and that is part A of the problem. I will get everything organized and then I will work on part B. Okay, so I went ahead and wrote out this next part. And so we basically have everything happening in opposite directions this time. So first we're going 20 meters in a direction 40 degrees south of west, and then we are going 12 meters in a direction 20 degrees east of south. And we want to figure out how far we've gone from our starting point and what the compass would say. So what angle are we at? So we'll go ahead and label theta. We can do theta in terms of south this time. Okay. So the first thing we want to do here again is find our components. So first let's look at the x components. So let's look at our first vector here. So our x component is here. And here's our angle. So this is adjacent, right? So we're going to say our x equals 20 times cosine of 40 degrees. And this is going that way, right? So this is negative. And then our next one, this one is positive. That's going back in our x direction. It's going back towards the positive. And we're looking at this component here. So with the way that these angles are laid out, this is actually going to be my opposite. So different from this one. If you switch what your angle represents so that it's always in the same direction, then those will stay consistent. I like to just look at each one as they come up because it just makes sure that I really understand what's going on in the situation. I feel like kind of memorizing a process is kind of like a shortcut. So this would be plus 12 times sine, then again, maybe that's why I have so many scribbles when I work, of 20 degrees. Okay, so this should give us our x component. So we've got 40 cosine times 20 negative plus 20 sine times 12 equals negative 11.2 meters. So I'm going to write that again down here. Okay, and now I'm going to find our y component. So now we're looking at this piece. Okay, so this is opposite. So this is going to be 20. Oh, and everything's going down. So everything's negative on our y component. Negative 20 times sine of 40 degrees minus 12 cosine of 20 degrees. And that equals 40 sine times 20 negative minus 20 cosine times 12. So that gives us our y component to be negative 24.1 meters. So we've got, here is our line. So we found out that this is 11.2 in the negative direction, and this is 24.1 in the negative direction. So that really shows you how poorly I did the angles here. I think this one probably was supposed to be a little bit shorter compared to that one. Anyway, now we can use the Pythagorean theorem to find the length of our r. So we've got 11.2, and it's negative, but if I make it negative and then square it, it's just going to become positive, so I'm not going to worry about that. Plus 24.1 squared equals that, and I square root that, and I get r to be 26.6 meters. Again, how fun. And then now we need to find theta. So there's theta. So we need our opposite, which is our 11.2, divided by our adjacent, which is our 24.1. And we get equals 24.9 degrees. And that is going to be west of south. Okay, I hope that helps.